Hello everyone. In this lecture of double-sided surface carrier, today we will take the current detection of the DSBSC. So what we have is the ST is the signal that we received at the receiver side. Then we use a local oscillator that will generate the carrier AC cos of 2 pi FCT plus phi, and both are multiplied in the product modulator, and then the signal is passed through a low pass filter where we get the output or the message signal. So first of all, is why we call this as the coherent detection. We call this as the coherent detection because the local oscillator that is used to generate the carrier should be exactly coherent, or we can say that it should be similar in the frequency and the phase with the carrier that we used at the modulator side whenever we used to generate the double sideband DSBSC. So the carrier that we used at the transmitter side, it is exactly the same in frequency and the phase at the receiver side. That's why we call that as the synchronous detection or the coherent detection. So what we have is we have the this as the signal AC cos of 2 pi CT. This is multiplied with the signal that we received at the receiver side. So this is the ST signal. So we multiply this signal and using the formula to cos A cos B or a cos A cos B, that is half this values. So what we have is we have this at concentrated. If we draw the frequency spectrum for that, so this will be available at f equals to 0, and this is available at minus 2fc and 2fc, that is represented over in this graph. So what we require this much part. So what we can do, we can use a low pass filter. So this is next, we'll see how we can get this. So first term in the equation 3.18, that is this is the equation 3.18. This equation the first term is removed by low pass filter. This is the term we are talking of. This will be removed by low pass filter, and we'll have this as the output. So this is assumed that the cutoff frequency of the filter should be greater than the W bandwidth of the message signal, but should be less than 2fc minus W. If it is greater than 12, then this we will have this part also available at the receiver side, which we do not require. Hence, the the cutoff frequency should be greater than this W and should be less than 2fc minus W. So this is what we get at the receiver side. Now here it also depends on the value of the phi that we are using. So the phase error phi is a constant, and if whenever this phi equals to 0, we have the output 1 by 2 AC dash empty. That is what we require. This is the message signal we took, and if we use this phi is pi by 2, so whenever this phi is pi by 2, this will be 0. So this will that will give rise to a quadrature null effect, and we don't have anything at the output. So when the phase error phi is constant, the detector provides an undistorted version of the original baseband signal empty over here. So we should take care in the double sideband surprise carrier coherent detection is that the local oscillator that is used to generate the carrier, it should be in perfect synchronization. That is, in it should have the same frequency and phase with the carrier that is used to generate the double sideband modulated signal in the transmitter side. So the resulting complexity over here is that the price is increased since we have to follow the synchronization at the transmitter and the receiver side for the carrier. Thank you.